Displacement vector in one dimension. Recall our Smilodon walking in the jungle and was at a specific position x at a certain time t. After a later time, the Smilodon moved a little further to the right from the origin. We know that the position vector r of t at position function x of t is equal to x of t I hat. And after some time, the object has moved further to the right, and if we will draw a vector from the origin to its final position, it will look like this, where our position vector now is denoted by r of t plus delta t. Our position vector r of t plus delta t is equal to the position function x of t plus delta t I hat. The displacement vector is denoted by delta r, that is equal to the position vector r of t plus delta t minus r of t. The green arrow in the figure is the representation of the displacement vector, which is also equal to x of t plus delta t minus x of t I hat. To simplify further, delta r is equal to delta x I hat, where delta x is the distance covered after time t plus delta t, which is the component of the displacement vector. As mentioned before, the component of a displacement vector is positive if the object moved further to the right as seen in the figure. It can also be zero if the object returned to its original position, thereby covering no displacement at all, which can be observed in the figure. And finally, the component of the displacement vector is negative if the object moved to the left from its original position as shown in the figure. Thus, displacement vector just describes the difference in positions between time t plus delta t and time t of the object being observed. Let us consider a moving car this time. We begin by placing a car at location A, where x is equal to 66 meters at time t equals 0. After 10 seconds, the car moved to location B at x equals 77 meters. At time t equals 20 seconds, the car is now at location C, where x is equal to 69 meters. The car continues to move, but this time to the left at location D, where x is equal to 50 meters after a total of 30 seconds. It went further to the left at location E, where x is equal to 31 meters at time t equals 40 seconds. And finally, at location F, where x is equal to 23 meters after another 10 seconds. The summary of positions at various times is given in the table on the left, and the graphical representation of this information is presented on the right. Recall that the displacement vector is delta r equal to delta x I hat. So, if we want to compute for the displacement from location A to location B, delta x AB is equal to xB minus xa, which is 77 meters minus 66 meters, equal to 11 meters. Since displacement is a vector quantity, we need to incorporate the unit vector I hat, meaning the direction is to the right. At this point, the other displacements of the car will be assigned as your exercise. Now, it is important to know that displacement is different from distance traveled. Distance traveled is the total length of a path followed by an object. It is always denoted by a positive number. For instance, in our previous example, if the car moved from location A to location C, the displacement is 3 meters I hat, or 3 meters to the right, while the distance traveled is 19 meters. Our next topic is velocity in one dimension.